So in today's class, we will learn Venturi meter. Venturi meter. First of all, what is this Venturi meter? See, it is a device. It is a device used for measuring the speed of incompressible fluid and rate of flow of liquid through pipes. So see, if from one pipe liquid is flowing and you want to measure the speed of that liquid, then we should use Venturi meter. Okay, what is the case? The Venturi meter is used to measure the speed of liquid through pipe. For example, this is a pipe, and now through this pipe some liquid is flowing with some, let us suppose, v velocity. So now how to measure the speed of this liquid? Then we can use this Venturi meter. That is what the use of the Venturi meter. Now let's see the diagram, okay, of this Venturi meter. Now this Venturi meter consists of two tubes, okay, like this. You just see how it is. I'm just drawing the diagram. Now you see here, this is tube A, this one is B, and this one is C. Okay, and this is U-shaped tube. Now through this liquid is flowing. Okay. Now see here, this tube A and this is C, in between B, it is narrow. These two are little bit bigger one. Now let us assume that the velocity of fluid through this tube A is V1 and velocity of fluid through this tube B is V2. Okay. Now, is area of cross section same here? No. Area of cross section is not same. Now, whatever the YouTube we have connected in this, there is another liquid. Okay, this is like a manometer. Okay, this is manometer only. Yes, no? And this is arm 1, this is arm 2, we can say, and this height difference is what? H. Okay. And this liquid is there, no? Its density is, let us assume that rho m, and the above liquid is having density, let us suppose rho. And always keep it in mind, what is that? This rho m is low than the rho, that is less than the density of this liquid which is flowing through this. Okay, clear? Now one more point, let at this point area of cross section is A1 and for this tube area of cross section is A2. And similarly the pressure at A point is P and pressure at this B point is P2. So this is P1 and this is P2. Clear? You have here pressure P1, here pressure P2. So at A, pressure P1, velocity V1 and area of cross section A1. Okay, clear? And at B, what we have? Pressure P2, velocity V2 and area of cross section A2. Now from equation of continuity, what is the equation of continuity? We know. What is that? P1, no, A1, है ना? A1 Phi1 is equal to A2 Phi2. Yes, no? A1 Phi1 is equal to A2 Phi2. Clear? And if I want Phi2, then from this I can find out. So that implies Phi2 is equal to A1 by A2 into Phi1. Is that clear? From equation of continuity, what we did, A1 V1 is equal to A2 V2, and from that just I have found V2 value, that is A1 V1 by A2. Okay, right. Now let's use Bernoulli's equation. So from Bernoulli's equation, from Bernoulli's equation. So let's move ahead. So from Bernoulli's equation, what I am writing here, see, P1 plus half rho P1 square is equal to P2 plus half rho P2 square. Here H1 and H2 are same, okay? That's why I'm not taking any potential energy here per unit volume, okay? So P1 plus half rho V1 square is equal to P2 plus half rho V2 square. And from this, P1 minus P2 is equal to half rho P2 square minus half rho V1 square. Now this half rho you take common, so you will get V2 square minus V1 square. Okay, right. Now this P1 minus P2, you take anything common, whatever you want to find, either V2 or V1. If I want to find, suppose V1, I am taking V1 square common. Then this is V2 square by V1 square minus 1. Is it clear? Check it once, right? Now V2 square by V1 square is what? From this you will get A1 by A2 into V1 whole square at the place of V2 square, and therefore P1 minus P2 is equal to half rho V1 square into A1 by A2 into V1, that is A1 square, A2 square, V1 square divided by V1 square minus 1. This you understood? This V1 square and this V1 square will get cancelled, and then I will get P1 minus P2 is equal to half rho V1 square into A1 square by A2 square minus 1. Check it once. Is it clear?
Yes, sir.
Okay. Now let's move ahead. Or first we will call this as equation number 1. Now you see in this manometer, this pressure difference is there, no? This pressure difference, how we can measure? From manometer, you will get pressure difference P1 minus P2, that is gauge pressure, you know, no pressure difference. So what is here? Not gauge pressure, just pressure difference. So you will get rho m into h into g. Call this equation number 2. Yes, no? Right, no? Now shall I write like this? From equation 1 and 2. Yes, what we will get? H rho m g H rho m g is equal to, what you will get this side? Half rho V1 square, half rho V1 square into A1 square by A2 square minus 1. Is that clear? Check it. Yes. Now I want to find V1. So I'm transferring all the terms except P1, everything this side. So I'm getting H rho mg, this 2 here. So 2H rho mg divided by rho into 1 by A1 square by A2 square minus 1. And this is equal to P1 square. And therefore, P1 is equal to under root of 2H rho m into G by rho into 1 by A1 square by A2 square minus 1. Yes, clear. Okay, this is what? Velocity. Now, if we want to find volume of liquid, passing per unit time, volume of liquid passing per unit time through the wider tube. Phi is equal to A1 into V1, and already V1 value we have. So this is nothing but A1 under root of 2H rho mg divided by rho, and this one I can write like this also. This part, if I will take it up and outside the square root, I can write like this also. A1 by A2 or A1 square by A2 square minus 1 whole power minus 1 by 2. Okay, clear? And or else, if you don't want like this, you take LCM also and substitute. So you will get something like this. This is under root 1 by A1 square minus A2 square, and this A2 square will come up. So that's why this is A2 square by A1 square minus A2 square. Clear? Any doubt? So this A2 I am taking outside. So A1 and this A2 under root this H rho mg, shall I write P1 minus P2? So 2 into P1 minus P2 divided by rho, and into this is 1 by A1 square minus A2 square. Yes, no? This is what? Volume of the liquid passing through the narrow end of the pipe. Any doubt, please ask. Any doubt?
No, sir.
This is what previous page. Note down now. Note down this page. So let's move ahead. Now in daily life, where we are using this, okay. So see here, sometimes you are getting question also in IP exam. So this is important. For IP, they may ask you question. So see, principle behind this meter has many applications. One of them is this carburetor. The carburetor of automobile has Venturi channel. Venturi channel means one nozzle through which air flows with large speed. The pressure is then lowered at the narrow neck and the petrol is sucked up and the
सर
petrol
एक बार
is
once back page you turn sir back page
1 minute you wait. Sucked up in the chamber to provide correct mixture of air to fuel necessary for combustion. Okay, next more examples. Filter pump, or aspirators, atomizers and sprayers, Bunsen burner also, atomizers and sprayers, these all are working on this only. Let me show you one small diagram how it works. I will show you the previous page. Just 1 minute. Let me finish this. Okay. Just wait. I will give you some time. Let me finish this first. You should understand this. Then we will move ahead. Now this is liquid here in this flask, and assume karo there is one straw type thing here which is dipped into the liquid like this. And now see, when this piston is pushed inside, there is a pressure difference getting created here at the narrow end of this, and what happens, automatically this liquid will come out. Understand? Same thing in spray also. Okay, even though there is no connection, but due to the pressure difference, this liquid will come up. It is like a petrol sucking up. Same thing in Venturi channel also. Okay, so this is what the thing or application, how the liquid is coming out even though there is no direct connection, just due to the pressure difference. Okay, so they may ask you the carburetor works on which principle, okay, and how it is or how the process is, which gives you the correct mixture of air and fuel. If you will see below the seat of your bike, you will get one air pump and carburetor and air pump. There will be one Venturi channel, yes, nozzle, through which air is flowing with large speed, and then fuel will be sucked up and all these things. So which gives correct mixture to the engine. What is that? Air and fuel. Let us know. That is what your this principle behind the carburetor. Okay. So they may ask you this for IP exam. This is what sprayers or atomizers diagram which I have drawn below. Okay. And see this the previous page. Note down fast. Yes, finished. Yes, finished.
Yes, sir. Done. Turn to next page.
Note down this.